this is Mr. Huff, and let's go through the alternate ending of this year, wrapping it up. Alright, part one is going to be prototyping and testing. So what I want you to work on through the rest of this week and weekend, if you need to, is you need to get some sort of prototype or model wrapped up that you can test. You need to get it to a point where you can do some sort of reasonable testing or analysis. This is the first priority, so if you can knock this out in the next day or so, that would be awesome. I don't expect you at this point, if you haven't finished it at this point, you're not probably going to have a perfect one, but you do need to have it to a point where you can say, hey, here's some evidence of my solution, if it's going to work or not. You also need to complete some testing, or at least make some projections and estimations. You need to test it in a way that produces numeric data. It can't just be, we tested it and it worked. You need to be able to talk about flow rates or forces or pressures or loads or whatever. So you need something that produces a numeric value, something you can make into a chart or a graph. Okay. And a lot of these, they may be estimations or projections about what you think is going to be happening. So if you do an estimation or a projection, it's not an actual data collection. Be clear about how you reach that data. You don't want to put something in there that makes it look like you did something that you didn't. And in the remaining time, I don't need you to complete all of your tests, but you do need to complete something. Okay. For your visualization, you're going to take that numeric data and you're going to produce a chart or a graph that meaningfully represents the data. So for this, I expect you to get as far as you can. If you run out of things to do this week or weekend, then you can work on shoring up some of the content you've already got and putting together some sketches or technical drawings about how you tested it and that sort of thing, or how you should have tested it. Some of that sort of content. So really focus on these three things this week: the prototype and model, testing and estimation, and visualization of your results or expected results. Phase 2 is the final presentation. I expect you guys to join us at the mile on Tuesday, April 27th at 8:15 a.m. to evaluate your peers. It will help you develop your final presentation if you see examples of other people that have gone through what you've gone through. All right. So this is the bottom line. Well, there's a couple of things here. Let me talk about this first. So first, we want to make sure that you just do this all in Google Slides. The PowerPoints are for people that are doing the presentation live. I need it in that format because my remote works with that, not Google Slides. So you don't have to worry about getting a PowerPoint put together. It's just a Google slide deck, so that's all you need to work in. Here's the bottom line, though. You need to document what you have. You've done a lot of work this year. It's not been fruitless. You do have a lot of evidence of your design process. We need to capture it. And again, let me stress, do not start this week. You need to wait until April 26th until you start putting this together. Don't shortcut what I've asked you to do so that you can go ahead and just get this done. Okay? I want you to actually try to do as much as you can on the prototype testing and data visualization. Okay? So if something is not done, then clearly state that it is what you expected to discover or learn about your prototype, and how that step guides your design. That's really the bottom line on every slide you put together, is how is this getting me to a solution? That's what your focus is on the whole thing. So you want to focus on your solution of your problem. So how does that content get you there? If you can't think of something, or you don't have any evidence whatsoever, then just put in the middle, go ahead and have the slide in there. Don't skip it, just have the slide. But put DNF in the middle, and that means did not finish. Just put it in as word art, so you would put something like this down here. Just drop it right in the center. Again, don't skip the slides, because your peer evaluators are going to be looking for these in this order, and if you don't have them, then it's going to make it hard for them to do the evaluation. So include slides. If you don't have any content, put DNF in the middle. Okay. The part one, and I have videos for all of these. They're linked later, but for part one, you've already got all of this. Some of the things you need to focus on is some of you have non-academic language in what you submitted before, so make sure you have uniform grammar throughout and you're using the common language. So just make sure you're proofreading it, clean it up, make it sound professional. There were some problems with some or problem justifications in that you did not have academic resources, and I've already asked you to fix that. I expect to see that changed here. I'll talk more about justifications in a moment. So just make, you already have all of this. Again, you might make, how I'm planning on you presenting this, or you're not going to present it, you're just going to give this slide deck to someone to review. So you probably want to have some things like at the bottom of the solution matrices, a little bit about how that process guided your design. You know, how did it get you to the solution that you picked? Okay, so the mind mapping, make sure that it's clear how you are approaching the problem, the three different strategies there that we talked about. Let's talk about solution justifications, not solution justifications, problem justifications. I'm asking that we change to a format similar to this because I was thinking about this in the context of live presentation. So you need to have your title of your justification here. You need an APA reference so that it's easy to see, hey, this isn't just me talking, this is a published work, it's an academic work, okay? And then a quote from the source, and it shouldn't say a quote from the source, just put the quote, okay? And then highlight, underline, bold, anything that is like a summary of important things. On the right side, these would be speaking points. So if I were presenting this in a live presentation, I would look at this and go, okay, we need to justify this problem. Did you know that 37.5% of all statistics are made up on the spot? So this is reminding us about how important it is to have credible and unbiased sources when we do our research. So that's kind of how that would go. So I wanted kind of a format like that. So you do have some tweaking to do, but it's not a lot on that. Same on part two, you should have all of this done except for maybe your notebook, sketches, model, and technical drawings. So there may be some holes in that, but you should have your design criteria and memo. You should have some content about parameters and specifications. You should have some connections to STEM concepts. All of this you should already have. On the survey and results, I have seen some people struggling with that. So really what you want to point out on those slides are, you should have come up with like 5 questions for your survey and really focus in on the 2 or 3 questions that guided your process. So really highlight those. Highlight, hey, these 2 questions, they were really helpful because they told us X, Y, and Z. Okay. So that's one of the things I've been counseling people in class. Instead of just going through every detail, it's like, what information guided your solution process. For the part 3, this is going to be new stuff. You need to put together a bill of materials and estimate a total cost. I don't expect this to be perfect. Just list the materials you need for your prototype and then how much they would cost. Then for the procedure of build, timeline of build, and evidence of the build process, this is the same content repeated 3 different ways. The procedure of build, you're going to list about 5 to 10 steps, just general steps. First, to build the prototype, you do this, and then you're going to do this, and then you're going to do this, and then just go through the whole build process, just like phrases about 5 words long, 10 words long, no more than 10 words. And then on the timeline of the build, you're going to take the procedure of build steps, put it into a table form, and then have a column that says hours per step, and then a total number of hours. So you should say, you know, step 1, that's like getting your materials together. That should take you 30 minutes. And step 2 is going to be assembling a frame, and that's going to take probably about an hour and a half. So you just go through, estimate how many hours it would take to do each step, and then do a total on the time it takes to build. And then evidence of the build process, you're going to take these steps here, make them captions for pictures. And you'll see this in the example video that I did, but we would have a picture of someone actually doing that, and it would be describing, hey, this is assembling the frame. And then you have a picture of it. So that's why I've been really pressing you guys to take pictures all throughout this procedure, because if you have pictures, they're in chronological order, and you can actually reverse engineer this from the pictures, starting with those pictures in order, going through your build procedure, and then estimating your timeline. Okay. Safety, and I know that we only did a couple, you only had to do like one formal safety poster for me. If you didn't get this done, just think about safety concerns throughout the build process. Identify about 5 rules you should be paying attention to make sure that you leave your process of building with all your fingers and toes. Okay. Tool selection is pretty straightforward. Testing plans, you did this. What I want these slides to show is a screenshot of your testing procedure, and then really what you need to do is explain how this is helping us validate your solution, what you expect to learn from it. You should have about 5. And then the next section is testing results. This is where you show what you learned from that. So I expect to see like a graph, some sort of visualization, and then a statement about what the analysis results are and how that guides your design process. And it's just like in science, you have a hypothesis and it's either supported or not. So your testing results could say, hey, it works perfectly, or it could be it almost does this, or it didn't really work the way we planned. So and then on some of these, since you're probably not going to have all your testing done, you would need to kind of have a mock-up about what kind of graph or chart you would put there, and then kind of explain again, this test, even though we didn't complete it, should have told us about our prototype, and we can't say for certain because we didn't do this test, but we think it would have said this or that. Okay. And then on the conclusion, you really want to focus on these things. You want to talk about, review your specifications, and you're going to talk about which ones you nailed, which ones you almost got, and which ones you totally missed with your prototype. You need to think about, the next slide would be, in conclusions, would be iterations. What would you do if you were going to build this again? What would you do differently on the prototype? It's just like I've been doing in engineering for the last 5 years. Always end with an improvement suggestion. So you're going to come up with a list of things you would do differently to make a better prototype, and then some recommendations to resolve problems that you had along the way. So again, in the video for part 3, I kind of go into some detail there, and I have an example for you to look at. So you can use that as a guide. All right, that's enough about that. Let's move on to part 4. I removed the formal evaluations because you're not going to get to present it to professionals. What I want you to do is replace that with a lessons learned slide. I'll talk about that more in just a moment. You will get peer evaluations. Go ahead and have the slot for the peer evaluation there. Then you need a slide for reflection on the process and reflection on the prototype and recommendations. And this is the process, we mean the engineering design process. Just, it's kind of expanding on what you have in your conclusion. Reflected on the engineering design process this year. What were some of the challenges, what went well, and what would suggest an improvement. Same with the reflections on the prototype. What went well, what was challenging, and what would you suggest as an improvement, and then recommendations for the entire process. So then on appendices, there are going to be some things that you worked really hard on that didn't make it into this final presentation, and this is a place to capture those. For instance, we did a bunch of drawings, technical drawings, that didn't make it into our presentation, but it was a lot of work that was done, so we put that in here as an appendix item. So that's what that appendices is for. All right. Here are some videos. These were intended for those that were that are presenting live, and even though you're not doing that, they still will walk you through part 1, 2, 3, and 4 if you have questions. And when you're done, I'm going to have you turn in a PDF. Let's just focus on that. So we're going to do a PDF when you're done. So let's talk about the lessons learned slide. This will be in lieu of your formal evaluations. I want you to think about this year and I want you to come up with 3 causes or problems for why you didn't hit your deadline and some things you could have done differently. So just again, this is kind of a reflection process. I want you to identify some clear problems and some clear things that you could do differently to resolve those problems, and then in a paragraph summarize what you learned through this year, the problems that you had, and the things you could have done differently right there. So it's just kind of tying it all up together into a little paragraph. You are going to turn this in by April 30th as a PDF for peer reviews. I will get some peer reviews for you in the first week of May. We'll get that to you, and then you're going to put those screenshots of those in, and you're going to talk about what you took away from that evaluation and what you would do differently. Again, what went well, what were challenges, and what you would do differently. Okay, and I'll try to get multiple for you. Once you get that complete, we'll do the wrap-up process where you can capture this entire effort. Again, you have done a lot of work this year. If you didn't get to the very last part of it, you still have useful and meaningful content that will open up conversations between you and people you can talk about. This is what I worked on in high school. That was not really a high school thing. So that's all I have for now.